Welcome back. So as we solve these systems by substitution, sometimes systems might have many solutions or infinite solutions. We call these systems consistent and dependent. Or they might have no solutions because they are parallel lines. So we're going to run into a crazy little set of equations that we just need to know, is there a true statement or a false statement? And I'll show you what that looks like. And I'll tell you in advance, if you have many solutions, infinite solutions, a consistent and dependent situation, you will have a true statement. I'll show you, don't worry. And if it is parallel lines with no solutions, they do not intersect anywhere, this will be a false statement. Let's look at exercise 4. So we start with the same process that we used on the first page. We have an equation. It is solved for a variable. X is all alone on the left. We are going to plug that equation into the other one for that variable. X, this quantity replaces, substitutes X. So let's plug that in there. And I have, as a result, 3.5 parentheses times the quantity of negative 2y plus 4. Close your parentheses because that quantity is done. Go back to the rest of your equation. Plus 7y equals 14. So we have substituted it in. Step 3 tells us to solve this equation for its variable. Okay, so to do that, I have to distribute this 3.5 through the quantity. Calculator time. 3.5 times negative 2. And sometimes you've got it and you know exactly what it is. And other times, you're just not quite awake yet. 3.5 times negative 2. Yeah, it's negative 7. So negative 7y. Let's distribute again. 3.5 times 4. So again, break out your calculator. And we discover that makes 14 plus 7y equals 14. All right. Hey, I've noticed something real quick. This is a negative 7y. This is a positive 7y. What is negative 7 plus positive 7? Nothing. These cancel out. So what do we have left? Not much. I have 14 on the left, and I have 14 on the right. That's a weird little situation, but does 14 equal 14? Like $14 equals $14? Yeah, it does. This is a true statement. It's no longer an equation with an X or a Y. It's a statement of being. 14 shoes equals 14 shoes. I don't know. So, yeah, as a result, I don't even have to go finish solving the system. I can stop right there and I can say, hey, you know what? Since this is a true statement, I know that this system of equations will have an infinite number of solutions where their relationship is consistent and dependent, because truthfully, it's the same these two equations are the exact same line. They're just written different. It's just written weird. So we're going to say infinite number of solutions, consistent and dependent. So it's weird. No argument there. It's weird. But it's done really fast. Like that a lot. Let's go check out exercise 5. So in exercise 5, we start off the same way. I have an equation. It is solved for a variable. Let's circle that up. And we are going to substitute this quantity into the other equation for its variable right there. So here, I don't even have a coefficient in front. I can just substitute it in. 3x minus 11. Go back to my equation. Minus 3x equals negative 13. What do you see? What do you notice in this equation? Yeah, your 3's. Your 3 x's? Exactly. One of them's positive, one of them's negative. What do they do to each other? Yep, they cancel out again. So what do I have remaining? Negative 11 equals, whoa, negative 13? Is that a true statement? No, those aren't equal. This is a false statement. So again, it's not an equation. It's just a statement of relationship because I don't have any more variables. It's just, does 11 equal 13, positive or negative? No, it just doesn't. So we see from our notes above, when you have a false statement, you have actually two parallel lines that never ever intersect. They don't have anything in common, and as a result, there is no solution. Done. So again, that problem finished up very quickly. It's weird. It is. It's weird. But it finished up really fast, and we got to see what was going on. Let's do number 6 together. Exercise 6. So this is our first word problem, and this is what I expect that your state test is going to hand you a lot of, is word situations, encouraging you to build the two equations and then go solve them as a result. So a snack bar sells 2 sizes of snack packs. Great. A large snack pack is $5 and a small one is $3. In one day, a snack bar sold 60 snack packs for a total of $220. How many small snack packs did it sell? All right. So, what are our two variables? We have, let's pull out our x and our y. X and y. So I know that there is a large snack and there is a small snack. We know that. So when you have a total amount of something, total number of all the things happening, what we see is that all of the larges plus all of the smalls make a total of 60 snacks that were sold. This is a total quantity of something that happened. And then we can talk about money. So money goes with money, which goes with money. Yeah, we like money. So the larges were $5. So $5 for each X, each large. And $3 for each Y, each small. And that made a total of $220. Money goes with money, which goes with money. All right, now we have written our two equations, and we just get to go solve them. So I don't have either one of these equations solved for a variable right now. I just don't. But I could solve one of them for a variable, and that wouldn't be too hard. So let's do that. If I took the x plus y equals 60 equation, and I solved for y, I would subtract the x on both sides. Solve for y equals mx plus b, giving me negative x plus 60. All right. We are going to now pick up just like we did with all of our other problems. Y equals this quantity of negative x plus 60, and I'm going to substitute it in to my other equation for the y. Let's do that. 5x plus 3 times the quantity, negative x plus 60, equals 220. All right, let's go distribute. Let's solve for x. 5x, positive 3 times negative x. A positive times a negative is a negative 3x. A positive times a positive is a positive 180 equals 220. All right, we've done the hard part. Let's go get it finished. Make it easy. I want to get rid of this 180. How do I do it? Subtract. What you do on one side, do to the other. $5x minus 3x. What is 220 minus 180? Yep, it's 40. What's 5x's minus 3x's? Yes, it is. It's 2x's. How do I get rid of this 2 and finish it off? Yeah, just divide. So how many x's, how many large snacks did I have? 20 of them. Cool. We found that we have 20 large snacks. All right, let's go grab the small real quick. We've done all the hard part. We're like home stretch. So we're going to take this 20 and I'm going to plug it in right there for that x. So y equals negative 20 plus 60. What is negative 20 plus 60? Yeah, it's 40. Y equals 40. Sweet. So now we can answer our question. How many small snack packs did the snack bar sell? 40 smalls. Ta-da! That is exactly the kind of problem I'm expecting on the state tests, but we're going to get so much practice with that, you're going to be a master. Don't you worry.